Hello, and welcome back to Calero Academy. Today we're going to be looking at a very fascinating problem which asks us to prove that any triangle can be inscribed within some circle. Now, at first glance, this is not at all obvious. If someone told me that there exists some triangle which is just too long, too narrow, or too wide, just too weird to be inscribed within a circle, I would at first thought believe them. However, today we're going to show for ourselves that this is not true, and that any triangle can be inscribed within some circle. So, we're going to break this video into two parts, within the same video, of course. The first part will show, in a very quick manner, that there exists such a circle. The second part will just teach us how to draw this circle around our triangle, using some basic things we know about our triangle. So let's draw the vertices of our arbitrary triangle. We know that there are going to be an infinite amount of points which will lie on a straight line, which will be an equal distance away from these 2 points. And it will chop the side length in half. For example, if the side was previously of length b, each one of these half sides will be b on 2 and b on 2. Now, on this line, let's just choose that magical point, O, let's say, that is a distance of r away from this point, and therefore a distance of r away from this point, but also a distance of r away from this third point. And that's it. Now we know that there exists a point O somewhere on this line that is also going to be a length of side r away from each of these 3 points. So, now that we have that out of the way, how would we draw our circle? We know that there exists such a circle, but would it just be guesswork? How would we find it? So, let us draw a circle, a badly drawn circle at first, but forgive me. Let us draw the triangle in here. We don't know what circle inscribes it yet, our triangle yet. So this circle is just for reference purposes to help us think about the problem. So we have our origin here, we don't know where it is yet, and we have a radius, r, which is the same distance away from all 3 of these points. Forgive the bad diagram. The way that we can find out how to draw our circle, is we need to find how far away the origin is away from one of our sides, and we need to find r, the radius. And we have to express those quantities in terms of things we already know about a triangle. So for example, suppose we know that this, we know it, it's a triangle. It's our triangle, we chose it. So let's have it have a side length of b over here, and let's say this angle be beta. Well, now let's draw our radii. This is going to be an isosceles triangle. By an interesting law of geometry, we will know that the central angle is going to be twice the subtended angle beta over here. Or to put it nicely, this one over here is just going to be equal to 2 beta. So, now let's draw this triangle over here, outside a bit for clarity. Let's draw a line straight down the middle of it, and call that h, being one of the things that we want to find. Let's draw our side lengths. Let's draw the 2 betas, which we get because we chopped this in half. Let's draw our right triangle, because we know, let's draw our right angle, because we bisected it perpendicularly. And let's draw our b on 2 and our b on 2. So, what we want to do now is just simply use some trigonometric ratios to find what we want. We know that h is going to be equal to r cos of beta. And we also know that r is going to be equal to 2 sine beta on b. If we plug that in now to h, we will get that h is going to simply be equal to 2 sine beta times cos beta on b, or sine of 2 beta on b. So now we have the 2 lengths that we need. Combining this and this, all we need to do is then find what these quantities are, which we will know in some specific triangle. Find where the origin is in relation to one of the triangle's sides, and then just draw all the points which are a distance of 2 sine beta on B away from that point, O. And that is going to be all for this Calero Academy lesson. Thank you for watching. As usual, if you have any comments, any reports of errors, any videos that you want to have us make, please just put them down in the comments area. And thank you for watching this Calero Academy video, and